Hi, thank you so much for attending this session. Thank you for giving me this opportunity. My name is Hesham and this is a part of my PhD thesis. And it's about something or one of most important and dangerous fields at AI, machine learning, which is natural language processing. And when we say it's important, because the importance of this field, it's increasing day by day. The spread of social network, spread of cell phone, spread of internet everywhere, make focus on natural language processing, text processing, it's increased day by day. Today we will talk about what's called embedding techniques for classification of star rating, and this is part of my PhD thesis. The aim of this study is very simply to apply word embedding to extract numerical vectors from the text, and then apply some of machine learning tools like clustering, like classification, and detect and assess what's the performance of these models to know whether the word embedding is it smart enough to extract numerical vector which reflect the under meaning of text or not. Is the word embedding techniques, is it smart enough to know that the gap between words house and apartment, it's less than the gap between house and horse. While the house and horse, they are almost the same letters. While house and apartment, they are far letters, but they are very close in meaning. So this is a question about word embedding techniques, and we'll see right now its performance at text classification and text clustering. This is a very simple representation of what word embedding means. That the relationship between man and woman, it's exactly like king and queen. And we know this is this famous equation, which is man minus woman plus king equal queen. And this is the smart tool of word embedding, whether it's able to extract the under meaning of words or not. And also, to get the relationship between cities and capitals and countries, as we see here at the right graph, like Ankara to Turkey, it's exactly like Ottawa to Canada, it's exactly to Moscow to Russia, and so on. If we are able to implement and to find a smart word embedding tool, it will make a revolution at social media. It will make a revolution at this era of text, since text is controlling everything in our life. And we will use text classification. Why? Because text classification is a very important tool to detect which category is suitable for this review. So for example, if we have hundreds of thousands of reviews for a specific brand, of course the brand owners, they need to know whether this review is positive or negative. They need to know whether this review is complaining about something or is supporting about something and so on. And we know that before the era of AI and text processing, brands and companies, they are paying millions of dollars to just know the exact opinion of their customers. For example, when iPhone released, iPhone 13, 15, 16, and so, they need to know your opinions. And they were paying billions of pounds and dollars to know exactly whether you are satisfied or unsatisfied, whether there's some complaints. Right now, it's very easy using natural language processing and text classification. We will use everything at Google Colab. And thanks for Google, because they are offering this wonderful tool for all researchers and developers, which is, it's a cloud computing, so you don't need any powerful computer like you would need like 10 years ago. Or even you can use your cell phone or your tablet to just use this Colab. It's cloud computing, and it contains thousands of useful libraries, which is very, very important at our work. Now, how about the Dataset which we used? My PhD thesis, it's about applying and implementing natural language tools to telecom customers exactly. And one of the most important platforms which contain reviews, positive and negative, it's a Trustpilot. It's not only in UK, it's worldwide. At UK branch, there's thousands and hundreds of thousands of brands and which contain millions of reviews, positive and negatives. So what I did, I looked into 10 most important telecom companies here in the UK. And then I used the Python code to scrape tens of thousands of reviews for everyone. And you know, if somebody used Trustpilot asks you if you will make a review to make a rank from 1 to 5, whether you are satisfied or not satisfied. So, if you are very satisfied with your company, you will give like 5 stars and you say, yes, this is a very wonderful company and good service and so on. And if you are unsatisfied, you will give maybe 1 or 2 stars. So I used a Python code, which is here. Okay, I will show it in a second. I used a Python code to scrap 2 things. First, the text itself and the ranking. So right now I have tens of thousands of reviews for all opinions of customers combined with the ranking values. So right now I can apply such classification and to exactly assess my classification because it's what's called a label data. So I can exactly apply multi-class classification or binary classification exactly as you will see in a minute. Here is like a sum or a number of reviews I scrapped. For example, Virgin Media Telecom. I scrapped 80,000 reviews. And this is like a combined of reviews for like past 5 years or something. And if you will see at the first row, you will see like 5 columns starting R1 to R5. R1, which is how many reviews ranking with 1 star. R2, 2 stars until 5 stars. So you can see that, like Virgin Media, I scrapped 80,000 reviews, 48,000 of them, it's only 1 star. 10,000, 2 stars, 8,000, 3 stars, and so on. And we can quickly find that majority of clients are disappointed. They have a lot of complaints, and majority of them are just focusing at 1 star and 2 stars. Right now, I have a fortune of data. I have what's called a multi-class classification datasets, which I can apply successfully a multi-class classification. And right now, in this chapter, but not in this presentation, I'm applying clustering to know whether the clustering tool like K-means, K-medoids, Gaussian, Bayes, whether they are smart enough to put everything as separated groups and whether these groups are homogeneous or not. Okay, and I need word clouds. And word clouds is a very simple tool to just represent for the user how many words and what's the most repeated words. This is a sample of a word cloud of one of companies, and this is like a real data. It's not just like a dummy data. So we can see that the most repeated words: service, phone, customer, time, contract, and so on. We can see that these words, it represents the content of the reviews itself. Of course, these words, it might contain a positive and negative reviews, right? And as another part, another graphs at my dissertation, but of course not here because I have a limited number of slides, I put a word cloud for only positive reviews, a word cloud for negative reviews, so it was very obvious what is main words appeared here and what are main points appeared here. And here is quickly the study design. Here is exactly the steps I followed to apply my steps. First, to apply data collection. Once I applied the collection, which is these tens of thousands of reviews, I said, okay, I need to know whether these classifiers, these algorithms, are able to apply at different types of datasets. So I created what's called radical binary classes, binary classes, and 5 multi-classes. Radical binary, which just I collected 1 star and 5 stars together. They are like polar values because they are very positive comments and very negative comments. And then after I applied all the classifiers I need, I asked myself, okay, are my algorithms are smart enough to detect stars or reviews with 2 stars and 4 stars? Because 2 stars are not very angry reviews, right? And 4 stars are not very wonderful reviews. So I made what's called the mixed binary to contain 1 and 2 stars together, 4 and 5 stars together, to check whether the algorithms are smart enough to detect them or not. And then I applied the multi-class classification to 5 stars. For each type of datasets, I have 1K, 5K, 10K. So for example, for medical data, 1K it contains 500 views from positive and 500 negative and so on. So I have right now 9 datasets. And then I apply model embedding. The most famous model embedding tool, there are several things like LOF, like TFD, RDF, like Autovic. So I said I need to make a comparison between their performance. So I applied TF-IDF, Autovic, Fast Text, BERT, and Autovic. And then I have an issue that, for example, when I apply Autovic to text, if I have like a review which is contain like 20 words, Autovic is able to extract the numerical vector for each word. So for first word, I have a numerical vector of 300 number. For second word, I have 300. For third, I have 300. How can I merge these numbers? What's the scientific and the correct way to make them? So I applied average to just take average all these columns and then PCA, which is principal component analysis. So I have 9 datasets, and then I have 7 word embedding. I apply, and then I have classifiers. I use the main or the important classifiers like logistic equation, random forest, gradient boosting classifiers, stochastic gradient descent, decision tree, support vector machine, and KNN. So I have right now a lot of combination. I have like 9 datasets, I have 7 classifiers, I have 8 classifiers and 7 model embedding. This produce hundreds of trials, which I do everything at Google Colab, and of course it takes months from me. Lastly, I use for evaluation precision recall and inference score. And this is why for evaluation, I focused on the feature extraction time to ask myself, how long each algorithm will consume. Some algorithms take just in part of a second, and some algorithms don't take so much. Also time to train the classifier, then precision, recall, and inference score, and lastly, because climate issue, it's very important for us. So I asked myself, how much energy it consumed for each model embedding and for each classifier? Because somehow we need computing process, and this computing process, it translated to CO2, which is produced in our environment. This is why also I calculated how much energy and how much CO2 consumed for each process. And I use several processing power like CPU, GPU, TPU, high RAM or not high RAM, and all these things available at Google Colab, but it needs subscription, not at the free version. And here is start or a part of graphs. I will quickly pass by them. Here is chart for feature extraction time. If you can see the right chart here, it's about feature extraction time using what's called T for GPU high RAM. We can see that there are several lines. These several lines, each one, it's about one of word embedding for here, like the green one, word to big average. The red one, word to big PC, and so on. We can see very clearly that at horizontal axis, 1K, 5K, 10K, and the vertical axis, which is number of seconds, so there are differences and consuming time for this. Of course, this is like a sample of tens of charts which I have at my dissertation. Okay, and then for fitting time. Algorithms, I first produce the numerical vector for code embedding, then I applied classifiers for them, which again consume a different values. We can see that this pyramid, which is for segregation, exactly for TF-IDF. Anybody is lucky enough to use TF-IDF, he knows that there is tens of thousands of features for TF-IDF. Logistic regression itself, it depends on like multinomial equations. So it's a very headache for logistic regression exactly to use TF-IDF. This is why it consumes a huge amount of time for us. While there is some algorithms like decision tree, it's very quickly for everything. Some algorithms like GBC, gradient boosting classifier, it very depend on the data itself. And then here is again the filling example, filling time, but it depends on the number of or the size of data, like 1K, 5K, 10K, and again I have tens of charts like this. I don't need to like waste your time in each part here and here. And then how about the performance itself? Here is the main point. How about the performance? Depend on precision F1 score for each one. I have this huge table, but we can quickly look at the yellow shadowed numbers. We can see values like this one, which is TF-IDF with logistic or TF-IDF with logistic but this is precision, and here is 1K, 5K, and 10K. We can see that generally some word embedding like algorithms like TF-IDF, it usually has a low performance compared by other things. Like for example here it's about 30, 0.3, 0.4, 0.5. So it's a very important inclusion. Do not use TF-IDF. It never represents the meaning of underworld, especially in this case. And we can see that there is a very wonderful numbers. For example, if we can see GDC column here, everywhere, numbers are very great, around 0.95, 0.96, 0.97, which show that, which reflects that this algorithm is able to detect very successfully the bill regardless of the type of word embedding and so on. If we can move quickly to the classifier performance, here is like a chart which is represent again the precision. Here is the F1 score. We have like some horizontal lines, like this brown one, which is for SCBC or KNN, while we have other classifiers which vary at their performance. And here, a very important thing, or a very important question arises for us while I'm working. Is the time consumed by classifier, is it correlated with the performance? It's a very important question, right? This is why I asked Python to make a chart with the horizontal axis with the precision, the vertical axis with the time. And I found there are several points here and here. We can see this abundant point, which is here, which is number 6. It's what, again, logistic regression with TF-IDF. It consumed a huge amount of time and the performance wasn't very great at around 0.3 something. One, we can see this cluster you see here, this cluster, and we can focus at point 2, which is representing it. Again, logistic regression with a word meaning called FT average, which is fastest average. It consumes, yes, the time it's not so much, but still the performance is not very good. When we can see this cluster here, and it may be represented by the point 51, which is using SCVC, support vector classifier, using TF-IDF. The time it's high, it's low, while the performance is very great. And we can see this cluster here, and it might be represented by point 22, which is using gradient posting classifier using Beard average, and the time it's high, but the performance is very good. And here, again, we ask ourselves, how about what's called individual classes performance? What's individual classes? When we apply a multi-class classification, I have 5 classes, right? 1, 2, 3, 4, 5. Maybe the overall performance is very good. But maybe one class, for example, class 2, it might have a very low performance. It means that, yes, the classifier is able to detect generally a good performance, but for this class specifically, it failed to detect or to predict its items. This is why I asked it, how about each item or each classes individually? If we see the right graph, we can see that the horizontal axis here, or the horizontal axis is from class 1 until class 5. We can see that class 1 and class 5 performance are very high, while the middle one start to be low. Why? Because maybe the reviews, if it was very like a 1 star, it's very angry words, or maybe 5 stars, it's very great words. So the classifier is able to detect it. While maybe class 2, 3, 4, which is number of ranks or number of stars, maybe the word is just mixed together. This is why classifier wasn't very good. Here's like, and how about emission energy? I used a library called emission tracker, which very easily we're using this Python code to just ask it to start and make your process and make end. And it will quickly detect the processing power, how many seconds or part of seconds you use, and it will tell you how much of energy you used, using what unit, and how many kilograms of CO2 you used in here. And this is a graph of results. The horizontal axis is duration. The vertical axis is emission at kilogram of CO2. We can see that some points, which is like, for example, these orange points, which is using A100 GPU higher. Yes, it produces a huge amount of CO2, which is very harmful to our environment. While some things like the green one, which is using CPU, yes, it takes more time, but it might be more friendly to our environment. And here is the conclusion, that some model embedding things like BERT or Dr.Vic, their techniques are more efficient than individual model embedding like Dr.Vic and fast text. Because some model embedding techniques, it consumes or it calculates the word embedding for the whole sentence, not word by word, which might be more suitable for this. Also, using PCA, principal component analysis, to analyze the number together, it might be more suitable than using average for each one. Also, some classifiers like session tree, random forest, KNN classifiers show generally a better performance than less filling time than other classifiers and so on. And the last thing is that, at some cases, using small size of data, it gives exactly as same performance as giving high or higher size of data, which means that having more data, it wasn't using helpful or useful for increasing performance, but it took or consumed more time and consumed more energy. Thank you so much. For any question, I'm happy to hear. Allows me to scrap the text and the range itself. Once I have everything as CSV files, so it was very easy for me to just pick and make it very balanced. For example, if I have radical data, so I'm 5,000, I have here 2,500, 2,500. If I have mixed data, which is contain 1, 2 together, as bad. 4, 5 together as good, and it was like for 5,000 I have here 1,500 for everything. And if I have a multi-class classification, I make it equal for each one. Why make this? To just make sure it's balanced, because generally balancing data, it might produce a more efficient results and so on. Yes?
So I want to say, why is it useful to be able to use the natural language to start with? Is there some application that we use?
Okay. Here we are just testing whether the natural language processing tool, especially word embedding, if it's smart enough to extract meaning or not. So this is why we apply it to a label data. We know indeed the rank of each label here and here. So if we apply like word embedding techniques here and then apply it classification or clustering, so we'll be able to assess it. If we have a high performance like here, at some cases, so we can apply it to unlabeled data. For example, if iPhone released like iPhone 17 or 18, and if they scrap millions of tweets about iPhone, they can automatically apply it, and within 5 minutes, they can know exactly the opinion of customers all over the world, and it will be very accurate. Why? Because it worked indeed at a labeled data. Any questions?
So you compared with a lot of these different algorithms, compared the amount of time that they can process and so on.
Yes.
Presumably you've seen Python, a lot of these algorithms have different implementations. Did you ever consider different implementations same algorithm. In my experience, they often can have like orders of magnitude difference in speed using the same.
Yes, that happened indeed. Actually, for each word embedding and for each classifier, and I looked for the most famous and most successful algorithm and library for this. And I have 3 years at my the PhD, and this is a part of it. This is why I tried tens and tens of algorithms until to find what is suitable and what's accessible and what is the algorithm which everybody says yes, this is working indeed. This is why I applied tens of it until I found these word embedding techniques, these classifiers, to find exactly how it works